Hey, grade 4 and 5, I'm here with more math for you. There's some fun stuff in here. Well, I think so. I love math. Do your best, work through it. If it's just you watching the video and trying it, so you can pause the video, try something, watch, or however it is that you found that these work for you. I hope that they're helpful. All right, let's go get some math done.
All right, grade 5, let's get started on our daily math. So today it's asking us, how many vertices does a rectangular prism have? A vertex, if there's more than one you say vertices, if there's just one you say vertex, and that's spelled like this, V-E-R-T-E-X. And those are just the corners. So how many corners? Think corners. 1, 2, 3, 4, 5, 6, 7, 8 corners. Has 8 vertices. Okay, number 2, name this shape. Now I'm just gonna move my phone over a bit so you can see the shape. Hopefully it doesn't fall. And we're gonna count the sides so we can name the shape, because you need to know how many sides a shape has before you can name it. So 1, 2, 3, 4, 5, 6. It has 6 sides. It is a hexagon. Hexagon. All right, how many parallel lines does a triangle have? Now, parallel lines, or they don't touch, so they run alongside each other like train tracks. So imagine train tracks. They never touch. They never get any closer together. So what it has here, it's asking it how many does a triangle have? So here's a triangle. Do you see any lines that do not touch on a triangle? Do they run parallel like a train track? No, they do not. Whereas if you look at this square, those are parallel lines right there. These are parallel lines right there. But right here, a triangle, there are none. So it's no parallel lines. None. 0. Number 4, draw a trapezoid. So trapezoids are like that table in the hallway in our classroom. Outside our classroom. So in between Miss LeBay's classroom and my classroom, there's a table. And it kind of is this shape. So it's got 2 lines that run this way, and then 2 parallel lines. See, this is these 2 are parallel lines. Right there, they're parallel. Imagine train tracks. And that is a trapezoid. So it's got a long line, a shorter line, and then 2 lines that join it together. All right, which pair of shapes look congruent? So congruent just means the same shape and size. Well, N and O spells no, but it's also N and O. All right, so the next thing I have here is for Thursday, I have a measurement. All right, for measurement, what unit of measurement would you use to find the width of a textbook? So there's all sorts of different widths here, or different ways that you can measure. So we've got, the smallest one is millimeters, then there's centimeters, decimeters, and meters. And meters you would use to measure something bigger. So I'm going to say centimeters for this one. It's probably your best choice. Okay. Now, the next one asks, what is the formula to calculate the area of a rectangle? So that is length. We've done this a couple times. You take the length, you measure it, and you times it by the width. And since you know about multiplication, you know it doesn't matter which one goes first, really, but it's length times width to give you the area of a rectangle. And the reason I say it doesn't matter which one goes first, so say this is my rectangle, and my length is 3 centimeters, and my width is 2 centimeters. If I do length, which is the longest one, times the width, 3 times 2 is 6 centimeters squared, because remember, it's talking about the squares, how many squares will fit in it. But if we do, oh, that was a loud but. If we do 2 times 3, 2 times 3 is also 6 centimeters. So that's why I said it's not a big deal if you mix up your length and your width, or you're not sure which one's the length, which one's the width. Basically, the one side times the other side is going to give you your area. Okay, what unit of measure would you use to time how long it takes you to shower? So I don't know how long your showers are, but I'm going to write these 3 here. So we've got units of time measurement. We have seconds. We have minutes. We have hours. We have days. Now, I really hope that your showers aren't long enough to go any more than a day, even any more than an hour. I feel like an hour-long shower would be quite a waste of water. Minutes is probably a good way to measure it, and seconds, well, you should be showering more than a few seconds. So let's say minutes. It takes us minutes to shower. We're going to measure the length of our shower in minutes. Okay, number 4, 900 millimeters, 990 millimeters. And how many decimeters is that? So to find out, you just have to divide so that's millimeters. And to turn it into decimeters, you have to move your decimal place 2 places. You have to divide it by, because there's 100 millimeters to 1 decimeter, you need to divide the millimeters by 100. And to do that, you take your decimal place and you move it 1, 2 places. Okay, so it's just like multiplying by 10. To divide by tens, you just move your decimal place 1, 2 places. 100 millimeters equals 1 decimeter, so 990 millimeters. When I move my decimal point, it's now 9.90 decimeters, or 9.9 decimeters. Okay, the time is 12:34 a.m. What time will it be in 75 minutes? So let's count. 12:34. Now, I don't have my clock here, but I'm going to draw a clock. I don't have that clock that I have in the classroom that I can move the hands on and count, but that's okay. I don't need it. I'm just going to draw a rough sketch of a clock. When you're figuring out time problems, sometimes it's helpful to have a clock in your head. Okay? And we are going to start our time at 12:34. Okay? And we're going to count up 75 minutes. So my 12, my 6, my 3, and my 9, I've got them there. And hey, let's just do the rest. Oops. Count, Mrs. Oaks. Learn to count. 9, 10, 11. So what I'm going to do is I'm going to count 75 minutes. It's easier to count by fives. I know that we're starting at 12:34. So I'm going to count by fives 75 minutes. Okay, and then I'm going to think, okay, minus 1 minute because it started at 12:34. That's the easiest way to do it. Now, 75 minutes is the same as 1 hour is 60 minutes, and then you have 15 minutes to make 75. So 60 minutes plus 15 minutes is 75 minutes. So this is what our clock looks like when we start, and we need to count 75 minutes, or 1 hour and 15 minutes, because 60 minutes is an hour. So let's do 1 hour. 1 hour is 60 minutes. Our clock hand's gonna go all the way around, and it's gonna be 1:35 or 1:34, but we're counting by 5, so we're gonna say 5. And then we're gonna count 15 more minutes. So 1:30, oh, this should be here. 1:35. 10, so then 1:35, 1:40, 1:45, 1:50, and 1 minute before 1:50. Gonna go back 1 minute, and that's 1:49. 1:49 a.m. 1:49 a.m. I counted up 75 minutes, I counted up 1 hour, and I counted up 15 minutes. Now, if I wanted to count by fives and do 75, I could do that too. All right, so I'm going to count that up. I'm going to start here, and I'm just going to count to show you that you can also just hop ahead an hour and do 15 minutes, but I'm going to show you by counting. So I'm starting at, I'm going to move here's my minute hand. I'm starting at almost 12:35 in the morning, and I'm going to count 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. That's 1 hour. So it's 1:35 or 1:34. And then I'm going to do 15 more minutes. So 60, 65, 70, 75. And remember, I counted by fives, but I go back one because 34 is one before 12:35. Okay, so it's 1:49. I just want to show you. So we're going to switch to our view for the long division practice, and you definitely want to tune in for this. We are going to switch to the view on the whiteboard. Okay, so we're going to work with this big number with 42. So we're trying to figure out how many 42s, how many groups of 42 are going to fit into 588. Now you might be thinking, but I don't know my 42 times tables. That's okay. There is a trick to this. So just like long division with single digits might have seemed a little bit much at first, this is going to be okay, and we're just going to practice it, work through it. If all you do today is watch the video and then try it on your own, maybe for one or two of them, that's great. We will continue this on other days. You'll get more of these and we'll practice them, okay? So 42, does it go into 5? No, 0 times. I'm not going to do the whole rigmarole, but I'm just going to look at this, 58, okay? So that's, I mean, I'm not going to go, you could, 42 times 0 is 0, 5, bring down the 8. So I'm looking at the 58 here. Okay, so I'm going to follow the steps that we used for single digit division to do this. We're trying to figure out how many groups of 42 go into 588. Now, it's the same steps. It's just you might not know your 42 times tables. So it might take a little bit more thinking for you, but that's okay. So 42, we're going to look at it. Does it go into 5? No, 0 times. 42 times 0 is 0. Obviously, it doesn't, so we're going to work with this 58. Now, you don't have to do this step, but I'm doing it because I'm showing you this is the same as single digit multiplication or division. So 42 goes into 58 one time. 1 times 42 is 42. Okay, and then you just subtract. So 58 subtract 42. 8 subtract 2 is 6. 5 tens subtract 4 tens is 1 10, so it's 16. Okay, does 42 go into 16? No, you can't fit that there. So 42 does not go into 16. Same as when we do single digits, we're just going to bring this down. Now 168. Now you need to do a little bit of estimation to figure out how many groups of 42 are going to go into 168. So to do this, you could think, okay, 42 is about 50, it's a little bit less than 50, okay? So how many, you could think, okay, 42, 168. Oh, or we could think multiples of 4. So how many 4s go into 16? Think about it. Right, so 4, you could get about, because again, we're estimating, you're going to get about 4 groups of 42. So let's try it out. So it's going to be about, because 4 times 4 is 16. 42 is like, imagine 4 groups of 10 and 16 groups of 10. And you have these other numbers, but it's fine. So let's figure out what 4 times 42 is. 42 times 4, okay. Just use your standard algorithm that we use for multiplication. 2 times 4 is 8. 4 times 40, 4 times 4 is 16. 4 times 40 is 160. So, oh, look, it fits exactly. 4 groups of 42 is 168. And we just estimated, now looking at, that's about 4 groups of 10s, and that's about 16 groups of 10s. We estimated, and it's exactly 4 times. So, 42 goes into 168 4 times. 42 times 4 is 168. We're going to subtract. There's no remainder. So do you see how we followed the same steps? The only thing that's extra is figuring out this little piece here, figuring out how many times 42 goes into something. You might have to do some estimation
and you might have to just figure it out. So for the beginning of working on this, maybe you're just watching the videos to help you through it, and that's okay. I'm going to continue adding this to our work, so don't worry. Okay, let's work on the next one. So my next one is 315 divided by 21. So let's get that set up here. Again, you're setting it up the same way as you set up, oops, just elbowed my computer there. Sorry guys, scare you a little bit. So 21, you're setting this up the same way as single digit division, divided by 315, okay? So how many times does 21 go into 315? 21 isn't gonna go into 3, okay, 0 times 0. I'm just doing this part to show you it's the same. If this is your process, you can also just look at 31. So how many times does 21 go into 31? It goes in 1 time. 21 times 1 group of 21 is 21. We're going to subtract for a difference of 10. Okay, does 21 go into 10? No, it does not. So we bring down this 5. Now we have 105. Now we're going to use our estimation here to think of how many times we think 21 will go into 105. So look here, you have 2 tens and you have 10 tens. How many times does 2 go into 10? 2 tens and 10 tens. Don't worry about the ones. 2 tens and 10 tens. 2 times 5 is 10. So what if we did 21 times 5 to figure out if that was a good thing to divide for by 21 times 5. Okay, 1 times 5 is 5. 20 times 5 is 10. Oh, that was a good estimate because it is 5. 21 goes into 105 5 times. So again, this extra step, guys, is just figuring out how many groups of your of 21 will fit in there. And we estimated using what we know about multiplication. We figured it out. Oh, we know now it's 105. So because you don't know, when you're doing single digits, you know those facts. You don't need to go and figure them out. The only difference with double digits is you don't know the facts, so you do need to go figure them out. Okay, 21 goes into 105 5 times. 21 times 5 is 105. Subtract, we have no remainder. So you've just divided using a bigger number. Again, this here is only so you can figure out how many groups there are. Okay, so you only need to do the little bit of multiplication just to figure out, because you don't know your 21 times tables. Or maybe you do. Congratulations, I don't know my 21 times tables. So I use this little bit of multiplication over here. It's like a sidebar just to figure it out. Okay, let's go on to the next one. Again, guys, if you're just watching this and doing your best, awesome. If you're watching this and it's easy, maybe you want to make up some more after this is done. You want to go and find some more to work on. It's easy. It's just a 3-digit number divided by a 2-digit number. So our next one is 276. Again, if all you're doing is watching me work through the steps today, that's cool. 276. So I've got my 3-digit number, and I'm going to be dividing it by 12. Divide by 12. Okay, so it's a really big division, Mrs. Oaks. Let's get to it. So 12 goes into 2, and remember this is 12 goes into 200, but for our purposes, if you keep following the steps the way we've done it, I'm modeling the process. If you keep following the steps the way we've done it for single digit, it's going to be the easiest way to learn this. So 12 goes into 2 0 times. 12 goes into 27. How many times does 12 go into set 27? You know your 12 times tables. It goes in 2 times. 2 times 12. You can fit 2 groups of 12 into 27. 2 times 12 is 24. Okay, you're going to subtract to find the difference. So I've got 24, subtract 27, 24, 25, 26, 27. I have a difference of 3. Okay, I subtracted, I've had a difference of 3. Does 12 go into 3? No, it does not. So I'm going to bring down my 6. Now, you might know your 12 times tables. I hope you know your 12 times tables. 12 goes into 36. 3 times, because 3 times 12 is 36. Okay, 3 times 12 is 36. 3 groups of 12 is 36. So 12 times 3, it goes in 3 times. 12 times 3 is 36. And we subtract to find the difference. Now, oh, I'm sorry. The glare on this is pretty bad. I hope you could still read it. If all you did today is work through these with me, congratulations. If you just watched the video and that's all you were able to do today, that's okay. Know that I'm going to keep practicing with this with you in the coming weeks. Know that you already know the steps. This is just taking it a little further with the bigger numbers, okay? So don't panic. We'll work through this together, and I hope that this video wasn't too confusing. This part of the video wasn't too confusing for you.
All right, now we are going to do problem solving using number lines. So problem solving using number line. So what we're going to do, it says problem solving using number lines. Alexander is running a 1 kilometer race. This number line shows how much of the race he has run so far. So here's 0, here's 1 kilometer, and there's Alexander. He's running his 1 kilometer race. It says answer the question. Has Alexander run more than half or less than half of the race? So to figure this out, we need to find the halfway point. So we'll figure out how many. This is 1, 2, 3, 4, 5, 6, 7, 8. So that half of 8 is 4. 1, 2, 3, 4. This is half because I am breaking it up into 1, 2 equal parts. So this is half. He has run more than half the race. More than half. What fraction of the race has Alexander run? So I counted and I know that there's 8 possible, it's out of 8 pieces. So I'm going to put my bottom number there, out of 8. Okay, my denominator. And then I'm going to figure out how many he's run. So we start at 0. Let's count. 1, 2, 3, 4, 5. He's run 5/8 of the race. Now it says, what fraction of the race does Alexander have left to run? So we need to figure out how many fractions, how many eighths of the race does he have to run to get from here to the end. So let's count. 1, 2, 3. So he has to run 3/8. Okay, now let's go to the next problem solving. Nicole and her friend TJ are collecting rocks. They've collected 12 rocks so far. 1/4 of them are black and the rest are gray. On the number line below, represent the fraction of the black rocks with a B and a fraction of the gray rocks with a G. So 1/4. So we need to break this line into 4 equal parts. So let's count how many pieces we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now what is 12 divided by 4? What times 4 is 12? Correct, 3. Or at least I hope you said 3. So we're going to break it into fourths. We're going to have to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So now I have 1, 2, 3, 4. I've broken it into fourths, right? Because the number line was broken up into even smaller pieces, but it's asked us to break it up into fourths. All right, I've broken it up into fourths, and it's saying now we're gonna answer the questions. We're gonna mark the fraction black rocks with a B. So this is B. These ones here are all black. Okay, and the rest are gray. G, 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 G. Or we could just say gray. All right, what fraction, write a fraction to represent the black rocks. So it's 1/4, or we could write it differently. We could go 1, 2, 3 twelfths. Those are the same, guys. It's the same. It's just looking at it a little differently. So we've broken it up into fourths up here. But down here, you can see the 12th. And we have 1, 2, 3 twelfths is the same as 1/4. Okay? How many of the rocks are black? So how many? They've collected 12 rocks. How many are black? 1, 2, 3 are black. What fraction represents the gray rocks? So we're looking here. How many fourths? 1, 2, 3 fourths. But remember, you could also write it as 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths. Those two fractions are the same. So up here it's marked in fourths, and up here it's marked in twelfths. It's just the same thing broken up into smaller pieces. How many of the rocks are gray? 9 are gray. Do the black rocks represent less than half or more than half of the total? So less than half or more than half. So half is going to be half of 12 is 6. So 1, 2, 3, 4, 5, 6. That's half. The black represents less than half. Less than half. All right, let's go on to the next one. Daphne spends 1 hour practicing the guitar. For the first half of the time, she does a lesson with her dad, and then she plays on her own for the last half of the hour. Draw a star on the number line to represent the fraction of the hour that she spends doing her lesson. So she spends 1 hour. This is her hour here. And she spends 1 hour practicing the guitar. For the first half of the time, she does a lesson with her dad. And then the second half she works on her own. So we're going to find our halfway point. So that's going to be breaking this into 2. Let's say right here, that's about half. Okay, and we're just going to represent it, or we're just going to mark it with a star to show that's halfway through her lesson. Okay, now our last fraction for today, it's saying we're going to put all these skills together. So these are all the skills that we've been practicing on with fractions, and now we're going to put it together so that it makes sense. This page is a review of all the skills we've learned so far. So you guys have learned a lot about fractions so far. We're going to put that all together, and we're going to work through these questions. Now, you know how to do a lot of these, so you might want to pause the video and do this on your own, and then press play so that you can mark your work. Let's try it. So again, you might want to pause this and work on your own, or if you're still not sure, you can work through it with me. But I think you could do this. All right, this picture represents a chocolate bar. The gray part represents the chocolate that has been eaten. The white part represents the chocolate that is left. What fraction of the chocolate bar has been eaten? So this is how much has been eaten, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. So our denominator is going to be 9. And our numerator, our top number, is going to be 1, 2, 3, 4, 5, 6. So 6/9 of the chocolate bar have been eaten. That is very small writing. Just going to zoom in a bit so you can see. What fraction of the chocolate bar is left? 1, 2, 3. So 3/9. Okay. Shade 2 leaves red, 3 leaves green, and 3 leaves brown. Now, do I have my colors close by? I might need to sub in brown for yellow. So 2 leaves red and pink for red. So I'm going to do red as pink. So 2 leaves, again, it doesn't really matter what colors you use. 2 leaves red, 3 leaves green, 1, 2, 3. I think mine are prettier anyway. And 3 leaves brown. And you can't really see my brown because it's yellow, but that's my brown. So what I'm going to do now, I guess you can see better if I was to do this. So what I'm going to do now is I'm going to work through it. So it says, what fraction of the leaves are red, pink? 1, 2, out of 1, 2, 3, 4, 5, 6, 7, 8. So my denominator, my bottom number is 8, and I have 2 out of 8, 2 eighths. My next one, what fraction of the leaves are green? 1, 2, 3, 3 eighths. What fraction of the leaves are brown? 1, 2, 3, 3 eighths. Okay, write a fraction for the number of gray cubes. So how many are gray? 1, 2, out of 1, 2, 3, 4, 5, 6. So 2 out of 6. Write a fraction for the number of white cubes. 1, 2, 3, 4. 4 out of 6. It says represent a fraction of the gray cubes on the number line below. So it's, again, we're going to have to break this number line into 6 pieces. So 1, 2, 3, 4, 5. So now it's broken into 6 pieces, and I have to represent it on a number line. So I'm just going to count 2. 1, 2, and I'm going to put a star here. Done. Sorry about that, guys. I did this without my camera being on it. So these are the 2 ways to represent 2/5, 2 different ways. So I have this one where I drew 5 circles, and I just shaded in 3. And on this one, I had a hole, a chocolate bar, and I broke it into 5 pieces, and then I shaded in 3 of them. All right, my next one, and I'm going to remember to move my camera. So it says, look at the star on the number line below. What fraction does it represent? Represent that fraction in 2 other ways. So looking here, let's look. 1, 2, 3. Okay, so I have 1, 2, 3 pieces. So my denominator is going to be 3. One way I can represent fractions is with numbers. So I'm going to draw the number representation. And then it's 1, 2. So it's 2/3. 2/3. Now, another way I could do 2/3 is to draw 3 dots and shade in 1, 2 of them, right? Because this is a set. So that's a whole. 2 out of the 3. Okay, on to the next. Or you could also, guys, remember, you could also draw a shape, split it up, and shade in 2 pieces. Okay, any of those are ways that we've been practicing to represent numbers. Okay, so now the last question of your day today, the last math question of your whole week. Aren't you excited to get this done? Write the numerator for each fraction pictured below. So all you have to do is write the numerator. Now, numerator is the top number. Denominator is the bottom number. So we're just writing the numerator, the top number. That I'm gonna write the fraction next to it because you know I have to, but because otherwise, you know, it's good practice for you to see them. Anyway, the numerator is this one right here. Now the fraction itself is 1, 2, 3, 4, 5, 6, 1/6. Okay, the numerator is 1, 2, 3, 4, 5. But the whole fraction is 1, 2, 3, 4, 5, 6. So the whole fraction is 5/6. I have to write the fraction. It just seems wrong not to. Okay, the numerator is 2. And just so you practice, the fraction is 2/3. Okay, this one here, the numerator is 2. But let's practice our fraction. 1, 2, 3, 4, 5. So it's 2/5. Okay, and my fractions here, 1, 2, 3, 4. And I have 1, 2, 3 shaded, so 3. And I have 3/4. Okay, you guys don't have to write the fractions next to it, but it's really good practice to practice writing and reading fractions. Next week, we're going to move on to some new stuff with our fractions, so stay tuned for that. Your next English day is Tuesday, so I will see you back here on Tuesday for another math video.
All right, you're done. Happy Friday. You're done math for the week. Woohoo! And next week, you will only have 2 English days, so I will see you back here for math on Tuesday. 2 English days. Remember, if you need some extra math practice and it's not, there's no lesson, you're done the lesson, you also have access to all of those math learning, the online math learning opportunities. So there was a list of websites such as SumDog and Reflex and Prodigy, but also Cool Math for Kids. And so any of those are cool, or play a math game with your family, or spend some time practicing your multiplication and division facts, please. Anyway, have a wonderful day. I will see you on Tuesday for more math.